Hello, 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 and welcome, everybody. Thank you for being here. There was some slight confusion with the link because we had to switch content for today, so I do apologize for that, but thank you all for being here. I see there's at least 15 of you here now, which is great. Okay, today we're talking concentration and density. New word to us today is density. We know what concentration means. It's how much of a solute is in a solution. That's what you're going to need. Science notebook, pencil or pen. Take notes, look at those observations. Okay? And then today's I cans. I can define density, and I can use tools to determine how dense a solution is. So, this idea of density has to do with two things, okay, that we've been talking about. One is volume, how much space some matter takes up in the universe, right? This is our syringe that measures in cubic centimeters or in milliliters, okay? Both units of measure for volume. And the other one is mass, right? We've been using these little mass cubies, or I guess they're hexagons, aren't they? We've been using these mass pieces. These are 5 grams each. Grams is our unit of measurement for mass. They're slippery. Whoa. Oh. You got to take a look at this. Hold on. So I dropped these 5-gram hexagons into these 2 containers down here. I'm very confused as to what's happening here. Wait a minute, let me try that in a more controlled fashion, because maybe because I did it on accident. Hold on. Okay, so wait a minute, what? Hold on. Hold the phone here. This one is floating on top of the water. This one sank to the bottom. What? Okay, hold on. Lily's saying surface tension, and she's an expert on surface tension, which is the tension at the top of a surface of a liquid. So what I'm going to try and do is I'm going to try and eliminate that surface tension. Okay? So I'm going to put them in gently, because maybe the idea is the surface tension is keeping one of them at the top. Okay, so I'm going to put them both in here. Aha, so they do both float. What if we tried it this way? So they do both float, so the surface tension is keeping it there. What if we put it in on the side? That one sank to the bottom. This one is still floating, even we can, hold on, let's try this. Let's try putting them in both at the bottom. Okay, eliminate that surface tension completely. This one still floats to the top. So even when we eliminate surface tension, this one still sinks and this one floats. Are you as confused as I am? Well, spoiler alert, I'm not actually confused. Ha ha! I planned it from the beginning. Here's what's happening with this. This one, on this side, is water. Just regular old water. This one is saltwater solution. Saltwater solution is causing our 5-gram hexagon to float when in fresh water it would sink. So what's going on here with that? Let's go over to I've officially already gotten salt and water on my computer to start this experiment. We're off to a great start. So let's talk about these things here. over here we've got mass, how much matter an object has, right? That's measured in grams. How much weight, how much matter, how many molecules a thing's got, right? And then we have volume, how much space an object takes up, right? Density, our word of the day, density, is the relationship between mass and volume. Okay, it's a proportion. In fact, we're kind of using division here. Okay, if we were to look at this like a math equation, we might think about it this way. Okay, mass divided by, and you can't see the dots because it's on a whiteboard, silly me. Mass divided by volume equals density. That's how you find the density of an object. Okay, you're going to take its mass, you're going to divide it by how many grams, well, you're going to take its mass, how many grams something weighs. You're going to divide it by its volume, how much space something takes up, and then you get its density in grams over cubic centimeters, or grams over milliliters, right? Remember when we talked about fresh water, how 50 milliliters of water equaled 50 grams in mass? Remember when we talked about that back in past lessons? Well, if we plug that into this equation, 50 grams divided by 50 milliliters equals what? What's 50 divided by 50? 1. Okay? And this gives us a nice and easy way to think about how dense something is, how much, how an object's molecules are sort of packed into a tight space. If you take the same amount of mass and pack it into a smaller space, so the same amount of mass with less volume, right, you're going to have something that's more dense, right? Let's say we had 50 grams of weight, but only in a 20 or 25 milliliter space, right? 50 divided by 25 would be 2 grams per cubic centimeter, right? Okay, so the idea that with water, the volume and the mass are equal, so we end up with a density of 1 gram per cubic centimeter. That gives us a nice way of thinking about it, of anything that the density is less than 1, so it's got more volume than mass, it'll float. Because the thing about mass is, and the thing about density is, the more dense something is, and the more, well, really the more mass something has, okay? And the more dense something is, the more gravity is going to act upon it, okay? So anything that is, the more dense something is, the more gravity wants to act on it, and it's going to sink, right? Versus the less dense something is, it's going to float, okay? So back to our original demonstration here, the reason that this 5 gram weight floats and this 5 gram weight sinks is not because it's got anything to do with the 5 gram measurements, right? Because these are the exact same mass and volume by design, right? These are the exact same mass and the exact same volume. So they have the exact same density. What's different are the liquids, right? By adding salt, and we saw this when we found the mass of our different salt concentrations, was that the more salt we added, or the more concentrated our solution is, the more mass it has. And the more mass it has, it means the more dense it is. Okay? So what that means is we've now found a spot where our 5 gram hexagon is less dense than the saltwater solution, so it'll float. And our 5 milligram hexagon is more dense than the fresh water. so it sinks in fresh water, but it floats in salt water. Okay? The more concentrated a solution is, let me grab some towels, because my paper towels, oof, because I dip my hands in the water again. The more concentrated a solution is, the more dense it is, because we've added mass to that volume. Okay? And thank you to those of you typing in the chat. Visitors, welcome. Thank you for tuning in. You're welcome to stay and watch, but we're, again, like our people say in the chat, we're, not having side conversations, just like we wouldn't have side conversations in real life, in the classroom. Okay? So our challenge today is going to be this. I've got, and I'll tilt this down here, I've got 4 different saltwater solutions, and I've color-coded them so we know that they're all different. Okay? We've got a green one, a yellow one, a purple one, and a red one. And our job is going to be to think about how can we figure out which one is the most dense. How can we figure out which one is the most concentrated and so is the most dense? So if we come back up to our original ratio here, let's consider this. We have this idea of mass divided by volume equals density. So essentially, the more mass, or by increasing the mass, the more dense. Okay? The more mass, the more dense. Also, the less volume, so to decrease the volume, you make something more dense. Okay? If you had, let's say, let's say you had a nice fresh piece of dough, right? It's nice and fluffy, nice and airy. And then you were to take that dough and you were to really pack it and squeeze it together as hard as you could, right? In that sense, you're not adding mass, right? You're not adding more dough. But you are decreasing the volume. You're making it fit into a smaller space, which means you've made that thing more dense. To spread it out and increase the volume would be to make that thing less dense. So, a great way to figure out if something is more or less dense, well, you could put them together and float them in water and see which one sinks to the bottom. You could do that. There was actually part of an experiment that we don't have the right straws for, so I'm a little miffed at the science department for, because they were supposed to give us straws that we can see through, and they did not give us straws we can see through, of actually taking these 4 different concentrations and actually making little layers of them, one on top of another. Okay? We're going to do it a different way today. Let's think about this idea. So if I have, right, more mass in the same amount of volume, we're going to be more dense, right? If we had, let's say our 50 milliliters, right? Okay, so the bigger this number gets, just like, if we want to write it as a fraction, right? Blank over 50. The bigger this number gets, the bigger our numerator gets, the more we've got, right? So if this was 100 grams over 50 milliliters, it's going to be more dense than 50 grams over 50 milliliters, right? Because 150ths is more than 50 50ths. Okay, it's just more, it's got a bigger value. Okay, so what we can do, and what we're going to do in just a second, is we're going to take these 4 mystery solutions. Well, they're all salt water, but the concentrations. We're going to take these mystery concentrations, and we're going to measure out 50 milliliters of each one. And then we're going to put them on the scale and weigh them. And we're going to know, because we're keeping our volume constant, That means the more mass we have, the more dense. Make sense? Let's give it a try. So we're over here. We busted out the electronic scale for this one, which I'm very excited about. Zoop. So we've got our 4 liquids here that I'm going to move to the side. I'm going to put out our electronic scale here. Okay, as you can see, it's measuring in, well, because I'm picking it up, it's kind of freaking out, but it is measuring in grams. Okay, now it's back to 0. And the first thing I'm going to do is I'm going to do what's called tearing the scale. Not T-E-A-R, like ripping it in half, but tear, meaning I'm going to put an empty container on the, I'm going to put an empty container on the scale. Okay, and you can see it weighs 11 grams. Then what I'm going to do is I'm going to press tear. So now I've reset it to 0, accounting for the weight of the container. Okay, so now when I add liquid to this container, all we're going to see on the scale measurement is the weight or the mass of the liquid itself. We've essentially subtracted or canceled out the weight of the, or the mass of the container. Okay, let's start with yellow, because it's the lightest color. And start with the yellow. We're going to take 50 milliliters from the yellow container, and we're going to add it just like that to our container. Okay, and we can see that we have 56 grams of our 50 milliliters of our solution weighs 56 grams. So I'm going to actually write that behind me. Yellow, 56 grams. Okay, and we're all measuring 50 milliliters of solution. So our volume's staying the same. So we know that whichever has the most mass is the most dense. Now let's try it again. And you can see we're back to, whoop, we'll tear it again. Let's see. I'm trying to dry this out here because you see we had 1 gram on there. It means there's 1 gram worth of there we go. Now we're back to 0. So now let's go to the next one. Let's go red. Okay, 50 milliliters of our red solution. What's the mass on that? It is 50 grams. 50 grams. What does that tell us? If 50 milliliters of the red solution weighs 50 grams, what is the red solution? And is it a solution at all? You guys are doing so well and being so patient. I really appreciate it. All right, next. Should we go green or purple next? We've got 2 more. We got our purple. We got our green. Let's go purple next. Let's switch it up. Okay, so we're back at 0. 50 milliliters, that's the green, 50 milliliters of the purple solution. Okay, in we go. And we are at 59 grams. 59 for the purple. Purple, 59 grams. Okay. So now, so far, I'll scoot to the side so you can see as I clean up here. Which one of our solutions is the most dense? If we're comparing the masses, all 3 of them were 50 milliliters. So the same volume. So whichever one has the greatest mass is going to be the most dense. So right now, yellow, red, or purple, which one is the most dense? Lastly, let's go to our green. We're back at 0 on the scale, which shows us we got all the liquid out that we possibly could to get it back to 0. 50 milliliters of the green. $50 milliliters of the green gives us 54 grams. 54. Okay. So let's take a look back up here and look at our data. So we looked at our 4 different solutions. We controlled the volume, so we had the same amount of milliliters. So we know that whichever one has the most grams, whichever one has the most mass in the same amount of space, is going to be the most dense. So look at our 4, yellow, red, purple, or green. Which one is the most dense? Which one is the next most dense? Which one is the third most dense? Which one is the least dense? Seeing there, the most dense, Ava believes that the most dense is purple. Okay, I'm going to put these in order. Most dense is going to be over here on my left, your right. Next most dense, so we're saying this one's number 1 for most dense. Number 2, which one? Yellow with 56 would be the next greatest. Then green. And then red. Okay, so we got purple, yellow, green, and red. So put them down here, purple, yellow, green, and red. There's our 4 different solutions. And I'll tell you what, I'm going to go in order of most concentrated. So the most amount of salt. The most salt in these 4 containers is purple. The next most salt is yellow. The next most salt is green. And then final one with no salt in it is red. So a perfect lineup there of least concentrated to most concentrated and least dense to most dense. So there is our connection, right? The more concentrated a saltwater solution is, so there's your answer to our question above. The more concentrated our saltwater solution is, the more dense our saltwater solution is. All right. Thank you for tuning in, everybody. We've got I like the green one. It's a good color, I will say. It is I'd say green and red are like the least transparent, right? Yellow's kind of light. The green's a good color. I'll agree with you on that one. Thank you all for tuning in. Exit ticket for the tacos is on Google Classroom. All other visitors, thank you for visiting. I appreciate you being respectful in the chat, and thank you for taking the time to come and learn some science. It's kind of some complicated stuff and some new stuff for 5th graders today, so I appreciate you giving it a try. Writing groups, my writing groups A and B, you have a meeting, so I will see you soon. Everybody else, go do the exit ticket, and you've got Makerspace and some game time later. Have a great rest of the day. Ciao.